Hello everybody, I am Nikhil Akalwadi, research scholar from Kerala Technological University, India. I am glad to present our work on DeFlare Net, flare detection and removal network. This is a joint work carried out with Allabaksh Kodesawar, Vinod Patil, Ankit Raichur, Swadroop Adrashappanmat, Sampada Malgi, Chaitra Desai, Ramesh Ashok Tabib, Ujjwala Patil and Uma Mudan Gudi. Flares in images are unwanted artifacts and typically comprise of light source and light streak. Flares generally occur in varying sizes and shapes. Flares in images occur due to the camera lens construction and the scene conditions such as the camera angle and the position of light source. While the use of special filters with lenses and other hardware equipment might reduce the amount of flares captured, one cannot completely eliminate the flares in an image. This motivates us to detect and remove flares to recover the true scene. Restoration using deep learning techniques often demand input flared image coupled with ground truth information. Towards this, we propose DeFlare Net, flare detection and removal network to detect and remove flares from images. The following is the overall framework designed towards detection and removal of flares from images. DeFlare Net consists of two main modules, namely light source detection module to detect light source and flares, and flare removal network to remove flares from the images. We train DeFlare Net using the proposed combinational loss function comprising of light source loss, flare loss, and reconstruction loss towards removal of flares from the images. Here we present the contributions made in this work. We propose a learning-based framework towards removal of flares from images and name it as DeFlare Net. We propose flare removal network to detect and remove flare inclusive of light source. We propose to include a light source detection module and detect and localize the light source. We propose a novel DeFlare loss, which includes light source loss, flare loss, and reconstruction loss towards removal of flare. We then demonstrate the results of proposed methodology on benchmark datasets in comparison with state-of-the-art methods. In this slide, we present the results of proposed DeFlare Net in comparison with state-of-the-art methods. The first row represents the input images. The second row represents results from authors in HTNFR. The third row represents results from authors in Flare 7K. The fourth row represents the results of proposed DeFlare Net, and the fifth row represents the ground truth information. We observe the proposed DeFlare Net preserves contextual information well and removes flares, thereby outperforming state-of-the-art methods. Here we demonstrate the results of individual modules proposed in DeFlare Net. The first column represents input images. The second column and the third column represents light source mask and flare mask as predicted by the light source detection module. The fourth column represents the final deflared images. Here we demonstrate the quantitative analysis of proposed DeFlare Net in comparison with state-of-the-art method. From table, it is evident that the proposed DeFlare Net outperforms state-of-the-art methods. To conclude, we have proposed a learning-based framework towards removal of flares from images and name it as DeFlare Net. We have proposed flare removal network to detect and remove flare inclusive of light source. We have proposed to include a light source detection module to detect and localize the light source. We have also proposed a novel loss named DeFlare loss towards removal of flares. We have also demonstrated the results of proposed methodology on benchmark datasets in comparison with state-of-the-art techniques using appropriate quantitative metrics. Thank you.